Hello friends, welcome you all to the lecture series of DBMS subject with the BCS 501 as AKTU code. Myself, Nitin Behal, Assistant Professor from ABES Engineering College. Welcome you all. Now today we are going to discuss about the very important points of the Unit 4, that is the transaction processing concept. In the previous video lecture series, we have already discussed about how we can find a serial schedule, what are recoverable schedules, what are irrecoverable schedules, what are stick schedules, what are cascadeless schedules. Now, another basic important point of this unit is, today we are going to discuss what is this is. The important point, that is log-based recovery, what are checkpoints, and how do we handle a deadlock. Now, this is a very important concept. We already discussed this in an operating system subject also. Now, the basic question is why do we need it here also? Now, it's a very basic concept is whenever we are working on a transaction, we are working on a data item. So all the story lies here. Are we able to get the data item for a particular transaction at that interval of a time or not? Or it has been logged or blocked by some other transaction. So let us see what are the log-based recovery, what are checkpoints, and how do we deal with the deadlock part. So what a log base says is, when we talk about a log, it's a kind of a book or record kind of a thing, a data structure which is maintaining something. So what is maintaining it something? It's maintaining a log. But when we talk about a log base in a transaction, so log is kept in a stable storage. So we are keeping up the stable storage. The log is a sequence of a log records and maintain a record of the update activities in the database. Now, the important point is whenever we do read and write operation, we have known that all these operations occur in buffer part. Once we have a commit, then this buffer is updated to the database part. But to order to check this thing, we have a log base. When a transaction TI starts, it registers itself by writing TI start in a log record. Okay, it started. Before TI execute write X, a log record of TI X, V1 and V2 has been initialized. Now we have four terms here, TX, Y1 and V2. Now T is a transaction, X is something we are writing on a data item X. Now what is the value of V1 is before the value of write of data item X, where V1 is the value of X before the write, that is the old value, and V2 is the value of the return to the X is the new value. Let us take X is equal to 50 and I has to X is equal to X plus 50. So then X become 100. So this become V2 and this is our V1 and we are saying write of X. Okay. When a TI finishes last statement, the log record says TI commit. We know that now we have to change it to the buffer to the database part. Okay. So this is something already we are doing it, but we are putting it in a log record. Now, how do we achieve these two things is by the two methods, that is deferred database modification and the immediate database modification. Now, by the name says deferred, it's something delayed part or after something. Okay. So what the deferred modification scheme performs updates of buffer or disk only at the time of the transaction commit. So it is deferred something. Okay, after. Whereas the immediate modification scheme allows updates of an uncommitted transaction to be made to the buffer or disk itself before the transaction commits. So one is before transaction commits and another is after the transaction. So by the name says it is the immediate one and this is the deferred one. Okay, so one is after the transaction commits and one is before the transaction commits and it updates for the uncommitted transactions. Okay. Now we have same thing like we have in a word like how do we perform a redo and undo operations also. Now what we have in redo and undo operations is, now undo is something going back and redo is a log record of TI X W1 D writes the old value of V1 to X, this one, and redo of log record says is writes the new value of this thing. So these are the thing kind of an operations we perform repeatedly when we're doing the log records, but it has some issues also. We're going to discuss that also in the future part. So what deleter says, it to do the new value, and undo says it will do the previous value. Now undo TI restores the value of all the data items updated by TI to their old values, going backward from the lost record of the TI. So basically we are going back and then updating the records for that and redoing the next forward, next value in moving in the forward part. It's written here. And redo is sets the value of all the data items updated by TI to the new values. To the new values going forward from the last record to the TI part. It's the same thing like control J and control X or control, we're going to the next part or we are undoing and doing. Okay. Now, this helps you out, but there are some issues when we repeatedly do these kind of activities. Now, to check these things, we have another important point that is called a checkpoints. Now, when we talk about the checkpoints, what is important point is we are putting some kind of a checking conditions at some interval of time. We need to check whether they are going in the right direction or something. Redoing or undoing all transaction recorded in the log can be very slow. Update the next one, update the previous one, update the next one, update the previous one. It will take a longer time. So what we need to do? So processing the entire log time consuming if the system has run for a long time. That's for sure. So the efficiency in the system performance is going down, and this is not we are going to working with it. We might unnecessarily redo the transactions which have already output their updates to the database. So what is the use of doing it? There is no point of doing it. So what we have to do is simply recovery procedure by periodically performing checkpointing. So we are doing something in a periodically manner, means after some interval of time. After time, sometime after time, we're going to these kind of activities. So this is a periodical check. It's not like once it's been done and it's been there, it will be done again and again. Okay. So what we are doing is output all records currently residing in the main memory onto the stable storage. So what we're going local, and we are putting up into the main memory to the local storage or a stable storage. Output all the modify buffer locals to the disk. We are modifying this thing. Write a log record checkpoint L. Now, if you see this thing, there is a difference between this thing, checkpoint L, onto stable storage. What we're doing is onto stable storage where L is the list of all the transactions active at the time of the checkpoint. Okay. All updates are stopped while doing the checkpoint. So this will, redo and undo have been escaped. So we can skip this thing by doing the checkpoint. So what a checkpoint efficiency is, it will increases the output time that was taken by the long redo and the undo operations. So that's why checkpoint plays a very important role when we talk about the efficiency of occurrence of the transactions in a particular system. Okay. One of the most important points when we were dealing with a transaction was the concurrency control. Now, what we will talk about the concurrency control in the whole unit was we need to get the data in the consistent state. So whatever the read and write operation we are doing it should be updated correctly in the database. And whenever a person recheck the values, we are getting the right value. Now, what the most important point is, whether we are able to get the access of a data item to the particular transaction to execute something at that interval of time. So let us take a scenario is like T1 is there, T2 is there, and T3 is there. So A wants to read A, okay, and they want to write A. In between, they want to read A. So we know that we can give an access of this thing, but this can create a problem. It's a conflicting instruction and so on. And maybe this would not be released and T2 has to wait. And similarly, T2 has read B and they have to perform write B here. So again, they have to wait. So what basically says is when we have some kind of situation like this, the deadlock occurs. A transaction is a deadlock if it is blocked and will remain blocked until there is an intervention. And for which thing is this blocked? For a data item or the same data item. Now, how do we see that this thing is? There are many algorithms like locking based concurrency algorithm may cause deadlocks because we can put locking. We know that we have shared lock and we have exclusive lock. What will happen to the shared lock? It can give you the access to the read write, but what happened to the this lock, exclusive lock? It will only give a read and write only when we have access to data item that only. So there are many kind of the concurrency algorithm which can lead to deadlock. Now, what are the things, how we can remove it and how we can check this? The best important point is, first of all, important point is wait for a graph. So if you see that if a transaction Ti is waiting for another transaction Tj to release a lock on entity, then Ti to Tj is in wait for a graph, and this we can say that they are in a deadlock condition. Now, one of the important points for the wait for the graph in this thing, if there is a cycle exists, we say that there is a deadlock, and this is one of the most important and easiest way to find out. Now, let us see what are the other things in the deadlock we have to cover up. So the first thing is deadlock management. So how do we deal with a deadlock, and how do we find it out, how we can prevent it, or how we can avoid it? So when we talk about deadlock management, first thing is ignore. Let the application programmer deal with it or restart the system. This is one of the most important point and the basic one. So mean that there is no deadlock, there is no resources, every resource is free to everyone, and so on. Another approach says prevention, guaranteeing that deadlocks can never occur in the first place. So we are ensuring that, or we are guaranteeing it. How? Check transaction managed initiated requires no runtime support. Avoidance. The most important point is detection potential deadlock in advance and taking action to ensure that deadlock will not occur, and it requires runtime support. For example, what are the transactions will require, which are the data items, and what are the data items can be logged and unlocked, and accordingly that. So we are doing avoidance, means before, preemptive kind of thing. We are getting information before it. Then the last is the detection and fire recovery. If we found it, we have to recover it. Allowing deadlocks to form and then finding and breaking them. As in the avoidance scheme, this requires a runtime support also. So again, avoidance is the best thing. Why we need to get detect and then recover it? Now let us see how they deal with these problems. Deadlock prevention. So if we want to prevent a deadlock, how do we deal with it? So all the resources which may be needed by the transaction must be pre-declared. So we need to declare prior to running of the transactions. For example, transaction 1 needs read A, transaction 2 needs read B, and so on. So if we say that transaction 1 needs read A, so we need item A here, and this item B here, and transaction 3 again, write A. So again, this thing is mentioned. The resources must only be reserved but not necessarily allocated to the priority basis. Unsuitability of the scheme in the database environment, it can create a problem. Suitable for the systems that have no provision for undoing the processes. So this can be applicable for those systems where undoing is not giving any kind of the problem. So still, what is the most important point in the deadlock prevention? We need to get all the information prior, which is not suitable for all kind of transactions. Okay. Again, deadlock prevention, when we have an evaluation pattern, we need to there. Now, reduce the concurrency due to the pre-allocation. We've already done that. Evaluation, whether an allocation is safe, leads to an added overhead. Again, we are adding something again. Difficult to determine partial orders. No transaction rollback or restart is involved. So we are talking about a deadlock handling. So what a deadlock handling says is reduce the concurrency due to the pre-allocation because we've already allocated. Evaluation, whether an allocation is safe, leads to the added overhead. Difficult to determine because in partial order, and no transaction rollback or restart is involved. So what we can say is we can have an evaluation on this thing. Now, deadlock avoidance, this is the most important point, and we can pursue with this thing so that we don't find any kind of a deadlock and the transaction goes in a consistent state. Transactions are not required to request a resource in a prior basis. That's the most important point. Transactions are allowed to produce or proceed unless a requested request is unavailable, only when there is unavailability in the pattern. In case of a conflict, for example, transaction T1 is also asking for A and transaction T2 is also asking for A. At this case, what we have to do is transaction may be allowed to wait for a fixed time of interval. See, the important point is wait for a fixed time interval. If it would be infinite time, again, we are going for a deadlock or a condition called starvation. We are going to discuss that also in the next one. Order either data items or these sites and always request locks in that orders. Okay. More attractive than the prevention in the database environment. So we can say that what is best in the avoidance part is we are not giving in the priority passes only there when we have in the conflict, we have to wait for it. Where in the prevention method, we want to get something in the priority pass, but it can give you a problem at the runtime. So that is the difference between the deadlock avoidance and the deadlock prevention part. Okay. Now we say that when we have a deadlock and we have to recover it deadlock. Now what are the case we have to recover it? When deadlock is detected that we have found it out and the system is built up in the deadlock, some transaction will have to roll it back, made as a victim to break the deadlock. Now, this selection is very critical and we need to do it because else the system would be in a deadlock condition. Select the transaction as a victim that will incur minimum cost. So, this rollback is also very important. Now, rollback determine how far a rollback the transaction should be. Total rollback, it means an abort to start the transaction and then restart it from the beginning, means total rollback. There is no another way we are going in the between part, but we are giving the final part. The more effective to roll back transaction only as far as the necessary to break a deadlock, and this is very, very important. So sometimes we can break or roll back a transaction where we can find it out, yes, like this. Okay, so we can do it properly also, or in a between condition also. Deadlock recovery. Now there is a condition where we says that there's a starvation part. Starvation happens if a same transaction is always chosen as a victim. So again, they have to wait, then they have to wait, and then they have to wait. So basically, they are putting up in a very long time of wait and include the number of the rollback in the cost factor to avoid starvation. So if a transaction is waiting for more than a long interval of time, then this kind of situation can occur. So I hope you have learned from the today's lecture what are the log-based recoveries, what are the undo redo operations, what are checkpoints, how do we deal the deadlock, what are avoidance, what was wait for the graph, what was deadlock avoidance, the preemption part, the detection part, and the avoidance part. In the next coming lecture, we'll discuss more important points of the unit 4 and other parts. I hope you have learned from the important points. We have taken the reference from these of the unit parts. Thank you.